Okay, the next part that we're going to work on is motion problems, and basically it's the same thing for the most part that we just worked on with the distance problems. We're still using the same formula, distance equals rate times time. Okay, but we're looking for something a little different this time. Okay, it says, problem we have on page 5. A train leaves Slayton traveling east at 80 miles per hour. An hour later, another train leaves Slayton on a parallel track, so it's going the same direction, at 120 miles per hour. How far from Slayton will the trains meet? Okay, so we're going to use that chart again. Distance equals rate and time. Okay, now in these problems, okay, we got a slower train and we got a faster train, right? Okay, we have the same kind of setup that we had before. We still have slower and faster, but instead of knowing a distance, now instead we know the rate. They're giving us the rate, and we know the basics of a time, right? They give us some information about the time. Okay, so there's your trick right there, is now we're going to be filling in different parts of it. Okay, so we don't know the distance they're going to travel. That's what they're asking for. How far from Slayton will the trains meet? So the D is the part that is the same. Okay, at some point they're going to be at the same distance, and that's what we want to know. Okay, so the rate. So the rate of the slower train, they're driving at 80 miles an hour. Okay, the faster train is 120 miles an hour. Okay, now it says an hour later. Okay, so the first train leaves at 80. An hour later, a second train leaves. Now you can do this one of two ways. Okay, you can put the t in both places, and it's up to you which way you want to do it. If you want to give the slow train an additional hour, so the slow train gets 1 extra hour of driving, you can do that. Okay, or if you want, okay, let me erase this. If you want, you can say the faster train has 1 less hour of driving. Okay, so it's up to you which way you want to choose. In the notes here, they do +1 on the slow train that gets 1 extra hour, so we'll stick with that because it's already what they have in their notes. Okay, so but it's up to you. You can do the slow train getting an extra hour, or the fast train getting a slower hour. Okay, or minus an hour. Okay, so now our equations for the slow train, you have D equals 80 times t plus 1, and the fast train is D equals 120 times t, right? Now, we're already solved for something that we both have the same thing. They both have the d's already solved for them. So all you got to do now is just set them equal to each other. So 80 times t plus 1 is equal to 120t. Okay? Now we distribute. 80t plus 80 equals 120t. Subtract 80t. And hopefully you can't hear my dog barking in the background. Alright. So we'll subtract 80t from both sides. Sorry about the bad line. 80 equals 40t. And we divide by 40. And t equals 2. Now, here's the problem. We weren't really asking about time, right? What we were asking about was distance. We wanted to know how far they went. Okay, so the problem is, yeah, now we know how long they traveled, but how do we figure out how far they traveled? Okay, well, all you got to do is put the 2 in for the t in one of the equations that you started with. Now, I'm going to suggest you do it in that one because it's less work. So distance equals 120 times 2. So the distance that they're going to meet at is 240 miles. Okay, so what you're doing here is you're initially solving for the time that we have, or if they give you the rate, okay, whichever it is, you're going to solve for that part, and then you got to use that information. So you need to make sure you're paying attention to what you're looking for. Okay, we're looking for the distance, and they didn't travel 2 miles. Okay, they traveled for 2 hours. Okay, so make sure that you're finding exactly what you need to find. Okay, there is a try this now at the bottom of the page. If you can, go ahead and give it a shot. If not, you can just keep on listening, okay, and we'll keep going. But give it a shot if you can. At least try setting it up, and then see how you do. Maybe you'll get it right. Okay. Okay, so I've already kind of set up my chart. I got distance equals rate times time. I got my slow and my fast. Okay, and I've done this before I've even read the question to you. All right, so it says a car leaves Hartford traveling north at 56 miles per hour. Another car leaves Hartford 1 hour later traveling north on the same road at 84 miles per hour. How far from Hartford will the second car overtake the first? And the cars travel the same distance. Overtake just means that like they're gonna run into each other, right? They're gonna hit each other. So, are they gonna get to the same point? So our distances, we need them to be equal. Okay. Now the slow car, it said, was traveling at 56 miles per hour, and the fast car is going 84 miles per hour. Okay, so the slow car leaves first, obviously. Okay, and the fast one also has time. We're going to go ahead, and you could do it either way you want. If you want to add an hour, because the slow car left an hour early, so it gets an hour more of driving, or you can take an hour off of the fast car. I'm going to go ahead and do adding an hour to the slow car. Okay, so our equations, I'm just going to put it over here to the side rather than writing them down below. So our equations are d equals 56 times t plus 1 and d equals 84t. Okay, so our d's are the same, so that means that these two are equal to each other. So we have 56 times t plus 1 is equal to 84t. Alright, so now we just got to solve for t. Distribute, so 56t plus 56 equals 84t. Subtract 56t from both sides. 56 equals 28t. Divide by 28. And the time is 2 hours. So they drove for 2 hours. Okay, that's the time. Now, we don't have our distance yet, right? And that's what they want to know. So we take our 2, we plug it into one of the equations. Let's do it the easy one. D equals 84 times 2. So the distance equals 168 miles. And there you go. So they drove 168 miles, and that's when they ran into each other. Okay, it was probably a big fiery crash. I'm just kidding, it really wasn't. Okay, so that is the motion problems. You can give those a shot now too. There's one more of these type of problems called rate problems. They're all basically the same idea, okay, but I'll make that in another video as well.